webinar on overcoming challenges in the evolving gas distribution and transmission market. So thanks everyone for joining. I will start getting on with this presentation because we've all got days to be getting on with this webinar here conducted by Oxford Flow. I will start cracking on into a little bit of an origin story of Oxford Flow. So Oxford Flow has spun out of the University of Oxford University, and we have made our name in designing and manufacturing innovative and game-changing pressure control and flow control equipment for a number of different industries, including energy, utilities, process, petrochemical, and many more to boot as well. As I said, we spun out of the university in 2015, and combining a very interesting level of academia and industry know-how, we are essentially forging the way forward into an uncertain future for gas transmission and distribution, but we believe that we have products, services that can move this industry forward all the way. So that's Oxford Flow in a nutshell. Some of you on this call have done business with us before, some of you have not, and some of you hopefully will be very soon. So a little bit about me, your presenter, Faris Churcher. I don't think I have my camera on, but I have horribly aged since this photo has been taken. I'm the principal applications engineer and the business lead for gas transmission and energy transition as well. I've been with Oxford Flow for just around 7 years, and my background is all in automotive aerodynamics, specifically in motorcycle design. And I'm a specialist in natural gas transmission and distribution systems, transition energy, and pressure regulator technology as well. So that is the background of myself and Oxford Flow. So I'll now go on a little bit into the scope of this webinar. So I'll tell you what this is first. This is an independent view on the wide challenges faced by the global gas industry today, based on the experience of a newcomer. And as a newcomer, Oxford Flow has been around for 7 or 8 years now. And in the industries that we work in gas transmission and distribution, that is considered a newcomer. So we are very new to this industry, and we have been taking a bit of a holistic view to how the whole industry is responding and the challenges that are faced by it on a day-to-day basis from many aspects as well. And when we'll finish off this presentation by asking ourselves what steps could be taken to reduce the experienced issues or mitigate them or learn from them as well. And I'll go into what this is not. So this is not a definitive list of issues experienced by everyone on this webinar, or by every single gas transporter or energy transporter or energy network. This is not a definitive list. So don't take this as gospel. And this is not a lesson or critique on how these networks operate and are run. So this is, again, just from our experience, my experience, some of our colleagues' experience, all around the world. So it's not specific to any particular area or any particular operating method. And by all means, don't take any of what I say as the silver bullet to all of the energy network's problems. These are discussion points. Anything that I bring up is a discussion point. Some of them will need to work, all of them will need to work with lots of other different solutions to solve those problems. Not any single one of them is a silver bullet. So those are the sort of ground rules set out. So where to actually start on this very complex topic here. So what I've done here is put in this title here of overcoming challenges in the evolving gas transmission and distribution market. So I've highlighted 3 kind of operative words there. It's overcoming, challenges, and evolving. And I've separated those out into actually what the dictionary definition of all of those things are. So, I'm sure all of you are familiar with what a challenge is. You face them every day in maintenance, in operations, all of those kinds of things. Challenge is also a verb, and that's actually what Oxford Flow, as you're all fairly aware, I believe, is doing. We are challenging the norms. We are challenging the way that these kind of systems should be working. Evolving, so to change or develop slowly and often into a better, more complex or more advanced state. Now, this verb can be attributed to the entire gas transmission and distribution market as a whole. I would challenge this to say, actually, it's not doing it slowly anymore. Things are moving at a rate of knots at the moment because of various things, which I'll come on to in a little bit. So moving very slowly is not an option. Things have to go through step changes very quickly, otherwise natural selection will run its course. And then overcoming. So this is the more positive end of the spectrum here. So, successfully deal with or gain control of something difficult. So that is what Oxford Flow and all of our customers and all of our network wants to do. We want to overcome these challenges by evolving at various different rates, ideally very, very quickly. So thanks very much for that. I'll give you a very brief overview of the gas transmission and distribution network. So this is just a graphic that we made not too long ago, showing the whole journey of gas transmission, gas production, storage, distribution, transmission, and then the end use as well. So this green section here is where Oxford Flow currently operates. So anything from transportation, refining, processing, transmission, storage, distribution, all the way to end users. Currently, we don't do much in the production side of things, and that is out of the scope of this webinar anyway. I'm sure we'll be running further opinion pieces and webinars on the production side of things as well, and the offshore and onshore production side. But for the moment, this is where we're focusing on at the moment. And to put this in perspective, in the UK alone, there is around 300,000 kilometers of transmission and distribution pipeline with 22 million homes connected. So infrastructure like that does have its issues and its challenges, and that's just in the UK. We are a very small little island in the North Atlantic, but the gas transmission and distribution industry is a worldwide industry with massive territories all over the world. So that 300,000 kilometers on a tiny little island is a drop in the ocean. So infrastructure like that, of course, across the world will have its challenges. So I'm going to come back to this slide a couple of times going forward. I'm sorry to say I have to now focus on the challenges side of things. So this will all sound a little bit like doom and gloom, to be honest. So what challenges are they? So how would we, when I started writing this presentation, I thought, how do we separate out what challenges there are? And I've had a go. So I've started putting them into three main sections. So first of all, we have legislative issues. So price control periods, Paris agreements, net zero agreements, and international panels mandating that certain targets have to be met. There are also socioeconomic challenges. So how does the wider society respond to gas transmission and distribution, to energy systems? How does that play into our challenges? How do people and how do the economic situations affect these things as well? It's a very, very wide aspect and very wide-ranging issue. So I've tried to boil them down to only a few. But obviously the last one, which is where a lot of you who have installed or have experience with Oxford Flow products can attest to, and that we are hopefully fixing a lot of them, is that there are technical issues with gas transmission and distribution. So equipment, operating methods, maintenance procedures, anything like that is all up for debate here. But granted, this is not a definitive list of all of the issues. There are it's a very, very wide-ranging topic, and we've only got 45 minutes for me to talk about them. So I've separated them into 3 sections. But essentially, all of these challenges are there because of these 3 pillars of energy operations. So when I mean those 3 pillars, I mean safety, I mean security of supply, and I mean resilience and future-proofing. Those in every single energy operation have to be at the forefront of everyone's operations, especially safety, because this is the gas industry. If things go wrong, then it has wider repercussions. So safety is always paramount. Okay, so I'll move on to technical challenges. What is the issue here? And I'll come straight into it and say, generally, there is a bit of a lack of innovation, and has been a lack of innovation in this area for some time. Some of the comments that we get when Oxford Flow presents its IMS gas regulators and its ES series control valves is that it's generally surprised because nobody has come up with this before. What we're doing is very simple. We're making things simple, we're making things lighter, we're making things more reliable. And that often means a step change in thinking. But there is a bit of a wider thinking. It doesn't apply to everyone, or by all means, by any means. But the lack of innovation often comes from a if it isn't broke, don't fix it kind of mentality. And the image on the right here is a common or garden pressure regulator. It's very simple. And they're very simple, but they also work. But they can always be made better. What we have is very simple: spring, adjusting screw, diaphragm, and adjustable orifice. So that is a pressure regulator. And that's generally what has been around for hundreds of years now. And this comes into aging equipment. So because this kind of equipment has been around for a very long time, with this if it ain't broke, don't fix it vibe, then that leads to equipment that it is not fit for purpose. And I'll come back to this evolving, to the verb evolve. Things can obviously go wrong, and aging equipment, it's useful at one time, and then as the networks evolve, as mixes change, as new problems come in, you can't use old methods for new problems. So this image on the bottom right here is one to be very aware of. Aging equipment is everywhere. And is the equipment ready for the next 20, 50, 100 years of technical challenge? Let's say we're moving towards hydrogen, towards different mixes of fuels, towards CCUS and carbon dioxide transport. Is existing equipment up to the challenge? That's all to be debated and has to be considered. Now, I'm going to go into a little bit of a lazy metaphor here around lack of innovation, because what I'm getting at here is it doesn't matter if you've come up with the best product in the world 100 years ago. If you don't carry on innovating, then you run the risk of being left behind when things change. And I'm going to start this off with an image of what is to me my kind of teenage years, or very early teenage years. This is a Nokia 3210, and I'm sure all of you are familiar with this phone, but it is essentially at one point, it was the best phone ever made, because its battery life lasted for weeks rather than my American manufactured phone, or my Google phone, as it is the Pixel 6. That will last for a couple of hours or a few hours before I need to recharge it. This lasted for ages, and you could throw it in water, you could bash it around. It met all the problems that everyone faced at the time. Yet, however, a quote from their former CEO was that we didn't do anything wrong, but somehow we lost. And I'm sure you can all make a generalized comment here in that I'm fairly sure that most of you on this call don't have a Nokia phone or haven't had a Nokia phone for many years. I'm happy to be proven wrong, but I'm probably right here. And this is a sign of Nokia, they just didn't innovate along with the times. When we look at this graph here around sales worldwide from 1999 through to 2021, 2007 was when their pinnacle of sales was 51 billion euros net sales. Then what else happened in 2007? Was actually the introduction of the iPhone. So suddenly this became, I'm not saying this Nokia was available in 2007, but Nokia came up with certain bits of innovation, but they did not keep up with the time. So obviously as smartphones became more and more prevalent, their sales dropped and dropped and dropped, and now Nokia aren't really there in that same space. So the moral of the story is new problems require new solutions, not a variation of old thinking. And that's something that, again, Oxford Flow prides ourselves on doing, is actually not sitting still at any one point and moving with the times or moving ahead of the times where we can. So size and weight issues, I'm sure anyone who's handled pressure regulation equipment and PRS stations around the world knows that there are packaging issues. With population growth and increasing urbanisation, this kind of equipment will not be suitable going forwards. We're going to have to start dealing with underground stations with proximity to residences, to areas that are previously inaccessible. But there's also a little bit of a wider issue in this industry, which we've noticed. And because size and weight is such an issue for a lot of this equipment, it is actually slowing down some diversification in the energy system workforce. And I mean that in the way that prohibitively large and heavy equipment can prevent 50% of the population, the worldwide population, from joining this industry. And I'll elaborate on that a little bit by showing you two pictures here. So what don't you see, or specifically, who don't you see in these photos? I mean, I've just shown two photos here, but there are thousands of photos like this on our database, and I'm sure on all of yours. And the answer to that is female workers. Everyone here is male, and large and heavy equipment, when it comes to health and safety, lifting risks, the recommended guidelines for female workers are lower than they are for men, but usually health and safety guidelines for safe operation is centered around the male population, not the female. And that is a very wide-ranging issue that needs to be looked at and solved very soon, because it's now 2023, and I'm sure all of you can agree that this industry is still very heavily dominated by males, and it can't go like that going forward, because it is alienating 50% of the population who could come up with the solutions that solve the problems for the next 50 to 100, 200 years. So that's a bit of an opinion piece. Most gas regulated technology weighs over 16 kilograms in certain pressure tiers, meaning this is lifting more than that above your elbows as a woman would technically be in breach of, especially in the UK, the health and safety executive guidelines for heavy lifting and safe lifting practice. So something to be aware of there. I mentioned population growth and urbanisation. So noise is becoming more and more of an issue now, as a lot of you are finding out, and especially us at Oxford Flow are finding out. The more you put these regulators closer and stations closer to population centres, the more noise complaints that people will tend to get, or the more technology is required to solve issues around noise emissions. And noise is a physical phenomenon that, physics is what it is. You can try and abate it, you can move the problem further away, but it does need to be considered very heavily. Proximity, as I mentioned, civilians near gas equipment with natural gas at the moment, but maybe that moves towards hydrogen and more explosive and more dangerous operating fluids going forward. Civilians and the general public, might not be, it might not be great to have people very close to gas systems all the time, and that is going to happen more and more. And this is just an example of regulators that we have installed. It's in an urban environment, pushing 60,000 cubic meters of gas through an urban environment is going to be noisy all the time. So we need to consider this going forward. And as a little bit of a statistic for this, this problem isn't going away. Urbanisation is only going to become more of an issue. So in 2018, 4.2 billion people lived in urban areas, such as what you see here. By 2100, which is a lifetime away, but that will move very quickly. That number will more than double, or is projected to more than double, to 9 billion. So we need to start really thinking about how we package gas transmission and distribution systems. Do we carry on with old equipment that is large, heavy, or do we go with something that is, innovative and new and small and light and compact? That's obviously not for me to decide, but it's something to consider going forward as well. There's also a bit of a public perception problem around our industry, so far as I'm aware anyway, in that natural gas, LNG, other forms of methane are obviously greenhouse gases, and they do have negative kind of connotations in many parts of the world, in many areas, many demographics around the world. There are lots of positives to this sort of fuel, but in many parts of the world they do have negative connotations that need to be turned around or adapted or just been made aware of. Safety is a big one. Now, I'm preaching to the choir here in saying that natural gas and the distribution and transmission of natural gas is an incredibly safe operation. It is the number of accidents, deaths, fatalities, injuries that come from natural gas transmission is incredibly low worldwide. You're more likely to get struck by lightning than you are to be in a gas explosion caused by network operators, or a gas incident caused by network operators. Those are the statistics. Having said that, it only takes one event, or takes very few events to turn public perception. So this image here on the right is actually in the UK, from not too long ago actually, where a gas explosion happened, and it was within a residence, so away from the gas networks or whichever operator it was, away from their remit. But this incident happened and it claimed the lives of a number of people. And as you can see, the scale of the disruption there is, people will see that on the news, the general public will see that on the news, and it turns the public away from natural gas as a clean and safe fuel, even though by far and away it is one of the most safe forms of energy transport and energy systems. It is fact that CO2 and methane, natural gas as it is at the moment, is a pollutant, is a greenhouse gas. Lots of the general public will think of natural gas when somebody says natural gas to them, they will think of this kind of image here of dirty natural gas. And even though, again, I'm preaching to the choir when I say actually a flare is the more environmentally friendly of either venting pure methane or flaring it off and converting it to CO2, which is a less violent greenhouse gas. However, that doesn't change public perception, and rightly so, because whatever happens, we are burning a greenhouse gas, and in the burning of it, creating a greenhouse gas. So the public perception wants us and wants the industry to move away from natural gas and from a CO2 and greenhouse gas producing field. And a more controversial one is around the public perception of fossil fuel producers. So as an example, in the UK gas industry, or energy industry, I should say, providers and producers were forecast to make around £170 billion in excess profits. Yeah. So that is a eye-watering amount of money. And when we are talking about in the UK especially, I'm talking from my experience here, from the UK's experience anyway, gas prices or energy prices have gone through the roof recently, and it's pushed a lot of people into very uncomfortable areas, very uncomfortable ways of living, because a lot of people can't afford to heat their homes. Whereas the likes of some of the larger energy producers making bumper profits, obviously there are windfall taxes involved in the UK anyway, which abate some of those, and in some cases have negative effects on the producers and operators, especially in the North Sea. So there are shades of grey to everything here. But as a result, the wider issue here around this public perception is that these kind of images are fed to the young innovators and youth of the world, and as a result, there is a possibility that they're not being drawn into this kind of industry. They might go into every other industry that there is, automotive, into finance, into pharmaceuticals, into medicine. But this kind of industry with these kind of public perceptions, that is a problem to be considered as well. And I'll put a little bit of a proviso on this, in that the public perception changes worldwide. There are some places where the public perception is incredibly different to that. And in fact, many places where the public perception is very different to this. But this is, as I say, a newcomer to this industry's view on what this situation is. So legislation is also a very powerful challenge to overcome. It often comes from a very good place in the government, world governments and environmental laws being issued from the Paris climate agreement for one thing, but there are many of these around the world. The UK committed to a legal requirement, net zero carbon emissions being achieved by 2030. So in order for the UK to deal with that and meet those conditions, gas compositions, energy systems, the whole way of operating needs to change. And this isn't an evolution, this is a step change in operation. We have to do something about it. And it might not be the most economical thing to do in the first place, but it's a step that has to be taken before things change, and maybe irrevocably. Sorry. There are also things like pricing control periods, which take a lot of this out of network operators' control. You have to be, you are only given, network operators are only given a certain amount of money to spend over the next 5 or 6 year period. In some places around the world, it's excellently successful, but in others, perhaps not. I won't go into the details of where, but price control periods have changing effectiveness worldwide. I must say, in the UK, in my experience, it has been very good, but this is my opinion, not anyone else's. So please, by all means, put messages in the chat, challenge me on it by all means. There was also more topically, this was only last week, the IPCC, so the Independent Panel or the International Panel on Climate Change report on emissions and basically the way the world is going to go. And it was a very stark warning from them. And that stark warning, and it's a final warning, act now or it's too late. And that again puts fossil fuel energy industry into stark relief with the public perception of this industry. I won't go into the details of this, but you know, it was a very damning report of the state of the world as it is, and things need to change incredibly quickly. And this means being open to new ideas and being open to radical ways of thinking. Obviously, while still maintaining those three pillars of safety, security of supply, and future-proofing and resilience. So everything has to be done with those three pillars in mind, but we do need to start working faster to get around these problems. And again, some shameless marketing here in that our CEO, Neil Poxon, was recently published with a little statement in World Pipelines and various other publications talking about this IPCC report. So by all means, do check this out and check out our LinkedIn page and our website for any more of this kind of thing. We'll be doing a lot more opinion pieces as Oxford Flow on energy futures and emissions and renewable energy, everything like that. So do please like and subscribe and pay attention to us going forward. So what I didn't mention here previously is other world events affected a lot of energy operations. Obviously, there was in 2022 in February, just over a year ago, the invasion of Ukraine by Russia, which really forced everyone to change how where they get their gas from. So the world, especially Europe, well, Europe especially had been, and the UK had been complacent in getting all of their cheap gas, or a lot of their cheap gas from Russia. But now, obviously, we're changing that. We've reduced our consumption of Russian gas down by 80 or 90%, and we are looking to different means. So LNG imports from other parts of the world, gas from Norway, and gas from other large pipelines, as well as renewable energy. It has solar energy, wind energy. It has really kicked off in the past year and a half because of these world events as well. Anyway, now for the nice bit. I realize we've been talking about doom and gloom for a very long time, so it's time to think about what we can actually do to get around these public perceptions, around the technical issues, around legislation, or following the legislation, but in a way that means everyone is still happy. People still make their money, people still get their clean gas, and all of that. So this is now we're not going to be focusing on the challenges. We're now focusing the evolution and the overcoming of these challenges. One of the main things is a change in perspective will drive a lot of this. So, as I mentioned before, new problems need new solutions, brand new innovation, challenging the norm. And this is one of our LinkedIn posts from very recently in Oxford Flow being granted a core patent for our pressure regulation technology. This was a step change in gas regulation and pressure regulation and flow control away from what has been the norm for hundreds of years, or from at least 100 years. And that's not to say that the regulators and other gas control equipment out there does not work. Far from it. It's been around for a very long time. But is it changing at the pace that we need to solve and meet these problems and challenges that I've mentioned? That's not for me to say, but it's something to think about. There is also this, asking about diversification of knowledge, equipment, experience. In our industry, it seems that, again, my opinion of this is that everyone is there's a very big population of people who know the gas industry and have been in it for a very long time. And actually changing that and bringing different perspectives in from different areas around the world or from different industries really changes things and really can change things. So I've got another lazy metaphor here, and it's around GB cycling. So Olympic gold medals for Great British cycling. So if we look at this orange trace here, so it starts off, in Atlanta 1996 in those Olympics, and we gave the UK and GB gained 0 gold medals. Sydney, they got 1. This is when Sir Chris Hoy joined the scene and started winning gold medals for us. 2004, Chris Hoy turned again and started winning. But suddenly, between 2004 and 2008, there is a 4-fold increase in the number of medals that British cycling won. And that is attributed to what is known colloquially as the Secret Squirrel Club. And I'll explain that in this section here. So the Secret Squirrel Club was basically British cycling's R&D centre. And previously, before 2004, this was all operated by cyclists, by former professional cyclists. And that was all they knew. They'd been a cyclist since they were 4 years old, and all of the problems were coming at from a cyclist's perspective. The Secret Squirrel Club, I should stop saying it because it makes me sound very silly, actually rejigged this whole R&D platform, and it brought in people from different areas, so automotive, from aerospace, from building technology and everything like that, away from, it obviously had the guidance of the professional cyclists and the lifetime cyclists, but new ideas just meant that in a 4-year period, a 4-fold increase in medals and in success came to GB cycling. And again, this is a very lazy metaphor, but funnily enough, who should be coming at this from a different point of view, from not valve and regulator world? I've mentioned myself, who's a aerodynamicist for automotive. We have in Oxford Flow rocket scientists, Formula 1 engineers, the heads of academia, but also industry heavyweights as well. So it's about combining those going forwards to basically emulate this British cycling opportunity. So I do apologise here. New problems, new solutions. Intelligence and automation, it's just taking learnings from different industries. So what we've done with our intelligent water systems out in the Middle East and in Mexico needs to be converted to gas, and we're working with a number of project partners on this kind of system, some of whom may be on this call or in this webinar. Using modern lean design and manufacturing methods means that we can move away from traditional modes of operation and technology from other industries. So, using brand new technology that just completely turns the operating mode on its head while still maintaining the same results, if not better, is the way to go forward. And we don't need to be limited to gas transmission technology and what has been there before and iterative solutions. It's technology from other industries. Oxford Flow designs equipment that was used in space exploration for power harvesting, and we're embracing the industrial and operational IoT, so Internet of Things methodologies as well going forwards. That will become a very important solution going forward as well. This is just an example of differing equipment then being replaced by new equipment as well. So evolution, new innovation, all of that kind of thing. Continuous improvement basically means that we can't just stop innovating. This is a graphic of, again, where Oxford Flow came from. We started out with one product, and now we've got a bank of maybe 20, 30 products, all suited to various different environments. So we need to do that, and everyone needs to start doing that more and more to end up with the optimal solutions. Again, this is an opinion piece, so don't take this as, these are the silver bullets to all of the problems. These are solutions to some problems, but it needs to be in conjunction with a lot of other equipment. And there's also something that I didn't mention in the challenges section was around this us and them mentality. Me coming from a reasonably academic background, I've often been treated as an academic and somebody who doesn't know what they're talking about when it comes to the industry. As, oh, well, a scientist will say something like that, won't they? But in real life, the operations side, we think this. And traditionally, that has always been the case. There's been a very big disconnect between academia and cutting edge science, and then what is going on in the world itself, in the operation side of things. Both aspects are equally important, and we want to remove the sort of barrier between that. This disconnect between academics and pure scientists and the rest of the industry. So we want to combine industry know-how and brand new thinking to solve wider issues. So that's where I introduce, Oxford Flow has partnered with a kind of very well-established, very kind of well-known industry operator from the upstream side of things in contend. We have signed a strategic partnership there, but I won't go too much into that now. But again, this is illustrating the point of contend have the industry knowledge, the industry know-how, the operational experience, but Oxford Flow supplies the innovation and supplies, what can we do and what can we step change to get through to the next stage of operation. So low carbon solutions, I have missed some things. So low carbon solutions, hydrogen and renewables, and fugitive emissions. These 3 points are incredibly important. I haven't spoken about them particularly in this webinar. Stay tuned for it.